Well, hey, everybody, Mr. Reeves back with you as we continue. Actually, this is our final video on lesson 8.3 solving percent problems. I'm going to go ahead now and solve some practice problems from the lesson. So here we go. Number one, a store has 300 televisions on order. 80% are high definition. How many televisions on order are high definition? Use the bar model. Okay, so remember when we are comparing these relationships, we have a percent relationship and we have a quantity relationship. So up here we have percents that go from 0 to 100. But our quantity, our sum, is not 100, it's 300. So again, 100% divided by 10 is 10%. So each one of these pieces is 10%. Well, 300 divided into those 10 equal parts is going to be 30. So each one of these is 30. So 0, 30, this would be 60, 90, 120, 150. Do you see how it's just going up by 30 every time? 180, 210, 240, 270, and 300. So these are the quantities divided up into 10 equal parts. These are the percents divided up into 10 equal parts. And they wanted us to find 80%. So 80% as a percent is 80%. 80% of 300 is 240. All right, so 80% of 300 is 240. Or another way to say that, 80 over 100 is equivalent to 240 over 300. Can you see that if I multiply this one by 3 and I multiply that one by 3, I get the equivalent ratio. 80 times 3 is 240. 100 times 3 is 300. 3 is what I'm calling the equivalency factor, which your book calls the multiplication factor. All right? Okay, moving on. Use proportional reasoning to find 65% of 200. All right, remember with proportional reasoning, we're going to have two ratios. One's going to be a percent ratio. The other is going to be a quantity ratio. All right. For percent, we're going to have part over 100. And for quantity, we're going to have part over whole. Okay. That denominator for percent will always be 100. The other three are going to change depending on the situation. All right. So I'm going to go ahead and write this like this. Okay. We have 65%. So right here, I'm going to have 65 over 100. All right. And then the question is, what is that? 65% is what of 200? Again, hopefully you watched those previous videos. If you did not watch my previous videos, you need to stop this video now and go back and watch the other ones. Because I talk about how the word of indicates whole. All right. So this is my whole right there. Whole, W-H-O-L-E. There's the whole part. And then this is the part that is missing. And then what we need to do is we need to find that equivalence factor, or again, what your book calls a multiplication factor. So I'm going to take the larger whole and divide it by the smaller, and I get 2. So that means that my equivalency factor is 2. Since the bottom number is twice as big here, the top number must be twice as big, and 65 times 2 is going to be 130. All right? So what does that mean? That means 130 out of 200, right, is equivalent to 65 out of 100. 65%. 65% is equivalent to 130 out of 200. All right? Or 130 is, let me write that another way. 130 is 65% of 200. All right. All right. Use multiplication to find 5% of 180. All right. So this multiplication method is the method that I briefly introduced and said I was not going to be going over it. Gosh, I'm not even sure how they want me to fill this in. Remember, of indicates multiplication. Okay. So when you see that there, that means if I want 5% of 180, I'm going to multiply. So the multiplication method says take that 5% and write it as 5 over 100 and then multiply it by 180, or you can write 5% as 0.05 times 180. And then I would simply do that multiplication problem. All right, 180, times 0.05. By the way, you could do this with the calculator as well. That would be 0. 5 times 8 is 40. Carry the 4. 5 times 1 is 5 plus 4 is 9. All right, and then I have two numbers after the decimal place. You remember doing this earlier this year? So we would get 9. All right, so 9 is 5% of 180. All right, which should make sense, right? Because 10% would be 1/10. 10% of 180 would be 18. So 5% is going to be half of that. So it's going to be 9. All right. Okay. Now, this is what I like. This is that proportional reasoning. This is the way we're going to be doing it. Part over whole equals part over whole. And we're going to have percent. And we're going to have quantity. All right. We're going to have percent. And we're going to have quantity. The great thing about these problems is you're doing the same thing over and over again. So once you get this process down, you could do any problem you want. All right, she spent $21 of her $300 on a gift. What percent of her paycheck was spent on the gift? So notice what percent. We don't know that percent, right? But we do know the denominator for percent is always 100. The denominator for percent is always 100. Now, 21 was the part of the 300, right? So we have the quantity part, which in this case is money, 21 over 300. We want to know what that is as a percent, right? So we want equivalent ratios. Well, let's find that equivalency factor. What are we multiplying by? It's 3, okay? And then the question is, what times 3 is 21? And again, if you want to know what you multiplied by, you can divide. 21 divided by 3 is 7. So Alana spent 7% of her paycheck on the gift. What does that mean? If she had earned $100 instead of $300, she would have spent $7, right? But she earned $300, so she spent 21. Those are equivalent. 21 out of 300, which she actually had, is equivalent to 7 out of 100, so it's 7%. I hope the more you do this, it just starts to make sense to you. All right, at Pizza Pie, get it? Pie, pizza pie. Yeah, all right. 9% of the pizzas made last week had broccoli on them. Yuck, that should be 0%. Okay, 9% of the pizzas. 9%, that means I have 9 out of 100. Here is my, come on, Mr. Reeves. That's a percent symbol. Here's my percent. 9 out of 100. Okay, so if they had made 100 pizzas, 9 of them would have had broccoli. All right, but they actually made 27 pizzas that had broccoli. So how many pizzas did they make total? So can you see? I hope you can see that our equivalency factor is 3. It would be 9 out of 100, but it wasn't 9. It actually was 27. So that means this bottom number has to be 3 times bigger, just like the top number was 3 times bigger. So how many of those pizzas did they actually make? They actually made 300 pizzas. Wow. And out of those 300 pizzas, okay, 27 had broccoli. Again, 27 out of 300. They made 300. 27 had broccoli. If they had only made 100, it would have been 9. And 100 is always the denominator for percent. All right? So they made 300 pizzas, 27 yuck with broccoli. All right? Okay. Let's go ahead and do some more of these problems. Excuse me. Sorry about that. I bet that was really loud in the microphone. Find the percent of each number. All right, 64% of 75 tiles. These are all being, they're giving us the percent and they're giving us the whole, okay? Each time you see that word of, it's an indication of whatever comes after it is the whole. So again, we're going to have two ratios. We're going to have percent and we're going to have quantity. Okay, two ratios are going to be equal. The whole part for the percent is always 100. We're going to have a part over 100 equals the part over the whole. And again, hopefully you've watched those videos where I said is an indicator of a part, of is an indicator of the whole. So 64%, that's going to be 64 over 100 is equal to something over 75. All right, 20% of 70. 20 over 100 is going to equal something over 70. All right, 32%. 32 over 100 is going to equal something over 25, and so on. All right? Now, this is where we're going to run into a slight problem, because now is where we would look for that factor that we would multiply, right? That equivalency factor. The problem is 75 doesn't go into 100 evenly, does it? 70 does not go into 100 evenly. Now this one works. 25 goes into 100 4 times. So that tells me that I'm multiplying by 4. So this one over here is an easier one because I could do 32 divided by 4 and I would get 8. So that would tell me that 32% of 25%, 32% of 25 pages would be 8 pages because the percent is 4 times bigger, right? 25 times 4. So what do we do? Well, again, if you watched my video, you saw that I said to try to simplify. 75 will not go evenly into 100. But what if we simplify 64 over 100? What will it be? All right, so I'm going to come over here and I'm going to look at 64 over 100 and say, what can I divide them by? Well, if I divided by 2, I would get 32 over 50. All right, but 50 doesn't go into 75, and 75 doesn't go into 50. If I divide by 2 again, let me show that. I'm going to divide by 2. If I divide by 2 again, what do I get? I get 16 over 25. All right, so now if I rewrite this, 16 over 25 equals something over 75. Now we're in business, aren't we? Because now I have a number that goes evenly into 75. I have an equivalency factor of 3. And 16 times 3 is equal to 48. All right, so that answer would be 48. So the correct answer, 64% of 75 tiles is 48 tiles. All right. Now again, I'm going to be honest with you. A problem like this may be using multiplication with a calculator, especially if you wanted to use the multiplication method for these problems. You could multiply 0.64 times 75, and if you did that in a calculator, if you change 64% to 0.64 and multiplied by 75, you would get 48. So for these ones that don't go in evenly, as much as I hate to say it, the multiplication method is probably a little bit more efficient. but this way works. You just have to simplify. Same thing here. If I take 20 over 100, I'm going to take 20 over 100, and I'm going to simplify that. Well, I'm going to divide them both by 20, right? Because I could divide by 20. Let me be consistent here and use red. So I'm going to take 20 over 100. I'm going to divide both of those by 20, and when I do that, I get 1/5. So 20 over 100, so when I rewrite it now, 1/5 equals what over 70, right? Now we can find that equivalency factor, and again, to find that equivalency factor, you simply take the larger one divided by the smaller one. 70 divided by 5 is going to be, well, 70 divided by 10 would be 7, so 70 divided by 5 is going to be 14. So 20% of 70 plants is 14. Of course, if you have memorized 20% and you knew it's 1/5, then you could say, well, 1/5 of 70 plants. I could simply do 70 divided by 5 directly and get that 14. All right? Okay, so again, we're looking for this relationship right here. Part over 100 equals part over a whole, because percent is always over 100. These ones would be set up the same way, right? And remember, if you get denominators where one is not a multiple of the other, simplify until it is. Or if that doesn't work, you can always fall back on the multiplication method. Okay? All right, what about some of these other ones? The reason I don't like focusing on the multiplication method is because it only works for that particular situation, and then you get to these ones and you got to do something different. But if you do it my way, it's just more of the same, right? We have our percent ratio, which is going to be the part over 100, and we have our quantity ratio, which is going to be the part over the whole. And remember, is usually an indicator of the part, and of is an indicator of the whole. That will help you know how to fill it in, because for every one of these problems, they're going to give us 3 out of the 4 parts. 3 out of the 4 parts. Well, the 100 is a given, so they don't have to give it. So for number 13, 4 students is what percent of 20 students, okay? So if I go right above it and I go to write my ratio, well, here's my percent, right? We don't know the percent. They didn't tell us what the percent was, but we do know percent is always over 100. All right, now, what is the part and what is the whole? All right, are there 4 students whole or 20 students whole? It's 4. See, this is 4 is. That tells me that the 4 is the part and the 20 is the whole. Makes sense, right? You're not going to have 20 students as part of 4 students. 4 students are part of 20 students, okay? So we read it. We set up our ratios. Now we want to find that equivalence factor. We want to make them equivalent. Well, thankfully, 20 does go into 100 5 times. If you didn't know that, you could do 100 divided by 20, and it tells you that it gets multiplied by 5. Well, 5 times 4 is 20. So 4 students is 20% of 20 students. Kind of weird. 20% of 20 students. Or 4 students is 1/5, right? 4 students is 1/5 of 20 students. All right. What about this next one right here? All right. 2 doctors is blank percent of 25 doctors. So it's the same kind of thing. They didn't give us the percent, so that's going to be over 100. We don't know what that is. 2 is the part. 25 is the whole. Then I'm going to find my equivalency factor. All right. 25 goes into 100 4 times. 2 times 4 is what? 8. 2 doctors is 8% of 25 doctors, right? Because 10% of 25 would be 2.5, so 8 makes sense. It's just a little bit less than 10%. Okay? All right, so I'm going to move down now because all 4 of these, you'll notice the percent was missing. Here, when we get to number 17, we've got the percent, but the number of days. So I'm going to look at number 17 right now, and I'm going to do it right next to number 17. Here we go. Same thing every time. I'm going to have my percent, and percent is always over 100. So there we go. 4 over 100, that's my 4%. That's my percent ratio. And then we want the is over the of. Here's our is, 56 days of what, right? This is our whole right here. This is the one we don't know. 4% of the entire amount is 56 days. 4% is 4 out of 100. We want to know 56 out of 100. Okay, so we need that equivalency factor. What do I multiply by 4 to get 56? All right. Now, again, this is a great time where a lot of them you could just look at it, but maybe you don't know how many times 4 goes into 56, so you divide. Well, 4 goes into 5 once, right? With 1 left over, and 4 goes into 16 4 times. So it's 14. 4 times 14 is 56. 8 times 7 is 56. 4 times 14 is 56. That means that this whole is 14 times bigger than that whole right there. So 4% of the answer is 1,400 days is 56 days. Do you guys agree 4% is the small amount? So if 56 is the small amount, we need to get a lot bigger. In fact, we needed to get 14 times bigger, and that gave us our answer of 1,400 days. All right, 60 minutes is 20% of how many minutes? So here we go. I'm going to set it up right over here. All right, so I'm going to write that ratio. Here we go. All right, 60 minutes is 20%. So there's my 20 over 100. That's my 20%. 60 minutes is over of. 60 is the part we don't know the whole. 60 is the part we don't know the whole. Let's find that equivalency factor. What do I have to do to 20 to get 60? I have to multiply by 3. So this one is going to be 3 times as big. So this one must be 3 times as big. So the answer is 300. Are you getting faster at these? Do you understand them now? Okay, we're simply creating two ratios. Percent always has a denominator of 100. We need to make them equivalent. In this case, the top was 3 times as big, so the bottom is 3 times as big. All right? 20 is 1/5 of 100. 60 is 1/5 of 300. They are equivalent. All right? Let me do a few word problems, and then we are going to be done. It says, at a shelter, 15% of the dogs are puppies. There are 60 dogs at the shelter. How many are puppies? So even though it's a word problem, they're just giving us the information a little bit different. Look for that percent. What's my percent? 15 out of 100, okay? 15 out of 100 of the dogs are puppies. 15 out of 100. But do they have 100 dogs? No, they only have 60. Remember, the key is going to be in that quantity. You're going to have to know what the part is and what the whole is in the quantity. The percent part's easy, all right, because the denominator is always 100 and the numerator is always whatever they give you, right? But this 60, the question is 60 the part or is 60 the whole? Well, they said there are 60 dogs at the shelter. All right. Okay, so dogs is our total, right? We're doing, our ratio is puppies to dogs, right? So puppies is the part and dogs is the whole. They gave us the dog, so that goes on the bottom. All right. Now, again, here's a case where when I went to do that equivalency factor, 100 does not go into 60 evenly. All right. So what am I going to do? I'm going to simplify 15 over 100. And you know what you can divide both of those by? You could divide both of them by 5. And when you divide both of them by 5, you get the equivalent ratio of 3/20. And now we're in business, right? Because 20 goes into 60 how many times? 3 times. And 3 times 3 is 9. All right, so there are 9 puppies. If there were 100 dogs, 15 would be puppies, but we only have 60 dogs, so 9 of them are puppies. Make sense? Less dogs, less puppies, the same ratio. 15% of 60 is 9. All right, Carl still has an MP3 player. Oh my goodness, break out the iPod. All right, of these 24 are country songs. What percent are country songs? All right, so this time, what don't we know? What percent? The percent is what we don't know, but what do we know about percent? Percent is always over 100, right? He has 200 songs, 24 are country. So again, country is the part, songs is the whole, right? 200 songs is his total. He has 24 that are country. All right, so again, you have to, the word problems, it's a little trickier because you don't always have that is of clue. All right, but if you think it through, puppies was the part, dogs was the whole. Country songs is the part over all songs is the whole, right? And this one is not too bad at all because 200 is twice of 100, right? So we know we need to multiply by 2. And if you take 24 and divide it by 2, you get 12. So 12% of his songs are country. Because if he had 100 songs, 12 of them would be country. But he has 200 songs, so twice as many, or 24 songs are country. All right. Let's see. I think there was one more I wanted to do. All right, I want to do this one right here, okay? Mark ordered a rug. He gave 30% of the cost as a deposit, and he will pay the rest when the rug is delivered. If the deposit was $75, how much more does he owe? Okay, so again, if we do our percent over our quantity, okay, so here we go. Our percent is 30%. All right, and then we have $75. Now the question is, again, we want part over whole, right? Well, that 30% deposit, all right, that's the part. 30 is the part, 100 is the whole. Deposit is a part. When you make a deposit, you're putting part of the money down, right? So that means that 75 is on the top, and the part we don't know is on the bottom. This would be the total, but we got to be careful here. All right, first of all, 30 does not go into 75 evenly, does it? All right, so I'm going to have to simplify. I'm going to simplify 30 over 100 down to 3/10, okay? And then I'm going to say 3 goes into 75 25 times. So what does that tell me? That tells me that the entire amount he owes, or the entire cost, is 10 times 25, or $250. The entire cost. So 30%, 30 over 100, is the same as 75 over 250. But that's not the answer to the question, and this is why I wanted to do this problem. The question says, how much more does he owe? Be careful. He's already paid what? He's already paid $75. If they gave him a bill for $250, he's going to go, no, wait. I already made a deposit, remember? So we have to take that deposit away. We have to do 250 minus 75. Well, 250 minus 50 would be 200. Take away 25 more, and we get $175. So he owes $175. If you add 175 to 75, you're going to get the $250. That's O's, Mr. E's, O-W-E-S. All right. Well, guys, I remember doing these type of problems when I was a kid and being confused. But you know what? I didn't have me as a teacher to explain it so well to me so I can learn it. So I really, really hope that having made those 3 previous videos of instruction, plus this video where I worked through practice problems by now, you can hit the ball out of the park because you know how to solve any kind of percent problem. Until next time, we'll see you.